Okay. In two-wire method of measuring effective diameter on screw thread, hardened steel wire is used. Hardened steel wires are used. So hardened steel wires are used for the measuring of the effective diameter on the screw threads. Okay, in this, in this, two wires, two wires of identical diameter, identical diameter are placed between the flanks, of the threads. That I will show you in the figure how they placed in between the flanks. See, this is a figure. So this is the flank here. So we have already told in the previous video, we will explain the terminology. These two are the flanks. In between these two flanks we are placing one wire. This is the micrometer anvil. So for the same like that of another one flank, we are placing here in between two flanks. This is the flank. So this is so overall the height is of how much? H, anvil height H, and this is the effective diameter E. So this is a normal figure with respect to screw threads and placing of the two wire anvil are placed between the flanks of the threads. Now I will tell you how to find out the two wire method. How to find out the this one pitch value for the two wire method. So only this part we have taken, only this part, only thread here. This is the flank. We are placing one wire here. Center here. This is the effect. This one effect is there, right? This line, effective line E, we are written here. So this is the effective E, and overall here from top H we are written, right? That H we are written here. H. This thread, in between these two thread, the wire is placed, right? This part we can call it as a, we are drawing one line. We have to mention A, also B, A, C, and for center of this wire, where the flanks, where the thread is mated the two flanks, we will draw one line. Touch the line flanks where the thread, the wire and the flanks meet. Now at that point draw a line from the center of that wire, that is O, D and E, with respect to angle of what? Theta by 2. So the distance from this line from to here is Y. So this is the wire diameter, wire of dia D, wire of dia D. So now we'll solve derivation to find out the pitch value, where E is equal to, as we know, the effective dia of the screw threads, where capital Y is equal to dimension under wires, that is minimum, that is the value we can call as H minus 2 into D. we can call it as a, capital H is the dimension over wires, that is maximum, and small d is the diameter of the wires. Now we will take effective diameter of the screw thread is given by E is equal to Y plus P. Now the effective diameter of the screw thread is given by E is equal to Y represent what? Dimension under wire. This E is equal to Y plus of pitch value P, where P is represent what? Pitch value. This is dependent on the pitch of the thread and wire diameter. It is dependent on pitch of the thread and wire diameter, that is D, and pitch thread of the P. So therefore it can be given as P is equal to 0.866 P minus of D. It represent what? Metric threads. In metric threads, this is the standard value where to find out the pitch. Capital P is equal to 0.886 P minus D for with respect to white over thread. So 0.9605 P minus 1.1657 D. This is the white over thread. This is standard pitch value formula. So now from figure B, here this is the figure number B and this is the figure number A. So from the figure B, we know E is equal to Y plus A into Q. E is equal to Y plus AQ. See here, there where E is equal to Y, distance up to here, Y plus up to here Y, A into this point we can call as a Q. DQ, this is point Q again Q, O with line meeting point D, here in another side E, this is Q, AQ plus Y, AQ plus Y. Now we'll consider triangle OEG. Here the triangle OEG, I can write it like here, another side. Triangle OEG, we have taken OEG, I have written here, that is theta divided by 2. So we want to find out the what is the OG value. To find out the OG, here OG is what? So this is what a hypotenuse. So this is the hypotenuse line. This is opposite, this is adjacent line. So to find out the hypotenuse, so we have to find out, we know the value of this one. So angle opposite line is what? Opposite this one, angle to the angle opposite to this angle we can call it as the opposite side. So we are applying sin theta by 2 is equal to what? OE by OG. Therefore OG is equal to OE into cosecant theta by 2. So this is sin 1 divided by sin means what? Cosecant. Therefore OG is equal to OE represent what? Y is the what? The diameter. In the figure we are here, Y is the what? The diameter. Diameter is what? D by 2. Y is represent, that is half of this one, right? This is half. Overall diameter is what? D. This half means D by 2. D by 2 into cosecant theta by 2. Write it here. OE represent what here? OE is equal to that is D by 2, that is equal to radius of the wires. This is what the radius. Y is the radius. Diameter is equal to what? Radius is equal to diameter divided by 2. So this where Y is equal to D by 2 we have taken, that is equal to the radius of the wire. Now consider triangle QCG, where it is, see here QCG. The triangle QCG taken one line, that is BC, line here, angle is theta by 2, QCG. QCG tan theta by 2 is equal to QC divided by QG. Here in the figure we are having QA is there, so we have taken it as a directly in place of A, we have taken it as a BQC. We have taken one triangle, this is BQC, whole triangle we have taken, we are consider BQC. We have to find out the QG is equal to QC into tan theta by 1 by tan means what? Cot theta by 2. Cot theta by 2. Now BC is equal to 1 by 2 into pitch, that is equal to half into small p, that is equal to 2 into QC. So therefore QC is equal to half into BC, that is equal to P by 4. So how it will be? We know that BC is equal to half into pitch, that is half into P value. We know that BC is equal to what? 2 times of QC. So 2 times of QC. So where QC is equal to what? This 2 it will come here means 1 by 4 into BC value. So we know that BC is we know the BC value here 1 by 2 into 1 by 2, that is P by 4, 1 by 4 into P. Then therefore QC is equal to what? P by 4. Therefore QG is equal to what? P by 4 cot theta by 2. Now the value of here QG and here OG. In the figure see here OG we have find out and QG also we have find out. So now from the figure B, OG is equal to OA plus AG. From the figure OA plus AG, OA plus AG, substitute the value here. We know that AG is equal to OG minus OA, that is equal to D by 2 into cosecant theta by 2 minus D by 2. Theta by 2. Also QG is equal to QA plus AG. QG is equal to QA plus AG. So now therefore QA is equal to QG minus AG. So P by 4 cot theta by 2 minus D by 2 cosecant theta by 2 minus 1. So where AQ is equal to what, or QA is equal to what, half of the pitch value, that is P is equal to 2 times of AQ, where AQ is what, half of the pitch value. So P is equal to 2 times of AQ, where 2 times of P by 4 cot theta by 2 minus D by 2 cosecant theta by 2 minus 1. So therefore final pitch value P is equal to P by 2, 2 ones are 2 twos are cot theta by 2 minus D, 2 will get cancelled, D into cosecant theta by 2 minus 1. So this is the final pitch value for the 2 wire method when we have to apply for the metric thread, where the metric thread theta is equal to 60 degree. We have to apply theta is equal to 60 here. We'll get P is equal to 0.866 P minus of D, and for Whitworth thread where theta is equal to 55 degree, we apply here, we'll get a P is equal to 0.9605 P minus 1.165 of D. So this is about the finding of the pitch value in the finding on the pitch value for the measurement of effective diameter by using the 2 wire method. In the next video I will tell you the how to find out the same effective diameter or effective diameter or pitch diameter using 3 wire method. Thank you.